Hi, everybody. I'm Marina, and today I'm going to present some results on data from the work I'm doing on my thesis. First of all, I want to talk about, today I'm going to talk about forest soils and their potential, their importance in climate change mitigation. To start with, I have to say that healthy soils are the second carbon sink on soil on Earth. They accumulate more carbon than the vegetation and atmosphere together. However, we have to take into account that 33% of the soils in the world are degraded or in danger. In this carbon sink, under sustainable management, this sink can last for hundreds and thousands of years as stable soil organic carbon or soil organic matter. In this sense, forest soils, as I said, has a great potential through carbon sequestration. And as we can see, I don't know where it is, okay. As we can see here, the IPCC estimated that forest ecosystems has the capacity to absorb up to 2.6 billion tons of carbon dioxide each year. And, which is more important for me, 50% of this carbon is above ground, so in the soils, underground, sorry, in the soils. So, in this context, in this study, we are going to talk about the mixed forests because depending on tree species composition, the production and composition of the leaf litter, the litter for the first floor, will be different, and so the quality and quantity of this soil organic carbon. So, in this study, we wanted to increase the knowledge about soil organic carbon dynamics and if the different species mixture percentage do affect the soil organic carbon stocks and their quality in a mixed forest of pine and oak. In this case, we are working with Pinus sylvestris and Quercus rubber. And we are going to assess the carbon in both places, in the litter fold, the first floor, and in the soil. To this end, we selected three triplets in the north of Spain, one here in the north of Palencia, in Aguilar de Campo, and the second one in the Pyrenees. There we had different plots with different triplets, which are formed by a pure stand of the pine, a pure stand of the oak, and a stand with a mixture of the species. But as we wanted to evaluate the effect of the different percentages, inside those plots, we established 39 circular subplots of 5-meter radius, covering a wide range of species mixture. This mixture proportion was calculated and expressed as a pine proportion or pine percentage. At each subplot, we collected the forest floor that was then divided into 3 fractions according to the composition state: fresh litter, fragmented, and humified. And also, we collected the mineral soil, and in this case, I'm going to focus only in the topsoil in the first 10 centimeters. All the samples were analyzed for carbon and nitrogen content, and carbon to nitrogen ratio and carbon stocks were calculated. In order to assess the effect of pine proportion in different variable studies, we applied linear mix models with SAS software. And we had two different models, one for the first floor and other one for the topsoil. So as we can see here in this table, pine effect, we can see it here in this column and in this one. Pine in the first floor did only have an effect on total organic carbon. And for the carbon to nitrogen ratio and carbon stocks, we only found differences among fractions, among these different liter fractions. For the topsoil, for the mineral soil, pine proportion only affected the carbon to nitrogen ratio. So, getting into the results, talking about the carbon content, we can see here the first floor, and as I said before, we had an effect, a significant effect of the pine proportion, and in this case, the interaction between pine and liter fractions was significant. And also, if you can see here, it's the square, because that means that the evolution will be quadratic, a quadratic trend. So we can see here that this is the fresh liter, then the fragmented and the humified. So talking about the liter fractions, the higher carbon content was in the fresh fraction and was getting lower as the composition state increases. And also we can see here around the 60–65% of pine, that where we find the highest total organic carbon values for these two types of lithophore. For the soil, no differences were found. Regarding carbon to nitrogen ratio, in the first floor, we only found significant differences among liter fractions, and the carbon to nitrogen ratio was decreased as the composition state did. And for the soil, we found an effect of the pine, and we can see how as pine increases, pine proportion increases, this carbon to nitrogen ratio increased until more or less the 70% of pine proportion where it has the highest values. However, we have to take into account that in terms of quality, higher carbon to nitrogen ratio means that this soil organic matter has low rates of humification, and then is less stable and has poor quality. For the carbon stocks, no differences were found with pine proportion, and the average accumulation in the whole profile was around 42 megagrams of carbon per hectare. But if we see here, the lithophore just is a bit small part, but when we look into this, the 42% of this carbon is provided by the humified fraction. And as I said before, this had lower carbon to nitrogen rates, and then it's more stable and has more quality. Again, for the soil, no differences. So, as a summary, in the first floor, the principal thing is around 60–65%. We reached the maximum in TOC values. And in the topsoil, the lower carbon to nitrogen ratio was found when the rates of pine proportion was lower, and the higher, so the poorer quality, was around 70% of pine. And no effect, and we found no effect on carbon stocks. So, as conclusions, in this study we wanted to answer two questions. Does the different species mixture percentage affect the carbon, the quality and quantity of the carbon accumulated in the forest floor? Well, we didn't see changes. So changes with pine proportion did not affect the quality of the carbon accumulated in the forest floor. And regarding mineral soil, regarding the topsoil, even though we did not have changes in carbon stocks with pine proportion, we can see that as pine proportion increases, carbon to nitrogen ratio does. So this carbon, this soil organic carbon, is less stable and has poor quality. Overall, these results suggest that increasing pine proportion in mixtures did not affect carbon sequestration in soils, but in some cases did negatively affect the quality of this carbon. Thank you.